Precalc fans, how we doing on this fine Tuesday morning? A little cloudy outside right now. Weatherman said it's supposed to warm up a little bit today and tomorrow, which would be nice. It was nice yesterday to be able to get outside and do some things. Yesterday we worked on Law of Cosines in the area. Did some gave you a worksheet with solutions. Continue to work on these things. Continue to push ourselves forward. Today, what we're going to work on is the Law of Cosines. Law of Cosines. Tomorrow what I will do is I will bring everything together in a review sheet with respect to law of sines, the area, and the law of cosines. That will be tomorrow. Thursday and Friday will be evaluations or anything that you need to catch up on. That will be the time. We'll do it on Thursday, but I'll make it due on Friday. So we'll sort of keep the same routine that we've done the last couple weeks. Once again, you've done it. You've been doing a nice job. Continue with the work that we've been doing here and continue to keep up with the material that we're working with. If you have things you still need to catch up on, please do catch up on them. Today we're going to talk about the law of cosines. We have properties of triangles that we've talked about before. We've done this in trig class. The angles, some of the angles of a triangle have to add up to 180. The smallest measure of an angle must be opposite the shortest side. The largest angle must be opposite the longest side. When the length of any two sides are added together, it must be greater than the third side. And when we have the right triangle, we have our good old buddy Pythagoras over there. We have leg squared plus leg squared equals hypotenuse squared. Okay, we have our Pythagorean theorem. Or we have our trigonometric Indian that we can apply to any right triangle. Sine, cosine, tangent, we can apply it to a right triangle. For any triangle, vertices are labeled with capital letters because this is the intersection of two lines. The intersection of two lines is going to be at a point. Points are labeled with capital letters. So we have two lines, two sides that intersect at the one point. They're labeled with capital letters. The side opposite the big letter is the small letter. So if this is big A here, angle A, this is little a opposite, big B, this is little b opposite, big C, little c opposite. If we take a look at, we'll just look at the little b here. If we want to solve for little b, we know this angle, we know this side, we want to find this side. You ask yourself, which trig ratio relates the angle to the two sides that we are dealing with? The side we know and the side we want to find. That would be the tangent of 73 is equal to opposite over adjacent, which is b over 10. And we can solve this by multiplying both sides by a value of 10, by a value of 10. So b would equal 10 tangent of 73, which we can clickety-clack through our calculator. 10 tangent 73, and we get 32.7. If we look at little c, just as a review, we have 73 degrees, we have this side and this side, we have adjacent side, we have the hypotenuse, so we have the cosine of 73 is equal to 10 over c. If you remember, when we have the variable in the denominator, we multiply by that c. They would cancel out. So we have c times the cosine of 73 is equal to 10. And then we'd have to divide by the cosine of 73. So we have 10 divided by the cosine of 73, which you can calculate a value then. Just a little review of what we did in trig class and also in geometry. But the problem we run into is not everything is going to be a right triangle. So how do we prove when we don't have a right triangle? Well, we have the law of sines that we can deal with, or we have what is called the law of cosines. And once again, developing your law of cosines equations, we draw in an auxiliary line, which is an altitude or a height of this triangle. We have big A here, this is little a, this is big B, this is little b, this is big C, this is little c. Now what we want to do is we want to create a relationship that puts all the angles and sides of this triangle into a relationship. Just like when we have a squared plus b squared equals c squared with the Pythagorean brotherhood, the theorem, we can utilize that. Well, that's only good for right triangles. This is not a right triangle, but we want to still create relationships between lengths of sides. So what we do, we have right triangle 1, we have right triangle 2. In right triangle 1, I need to add in one other value here. Okay, I need to add in a value here because I'm going to be dealing with just this right triangle and just this right triangle. So if I call this small value x, then this value here is going to equal c minus x. If this is a value of 10, this is a value of 3, this would be a length of 7. 10 minus 3 would give us the value of 7. So with this, we can write Pythagorean equations. If we have the first triangle here, we have, let's see, this is h, this is c minus x, and this is b. Using our Pythagorean theorem, h squared plus c minus x squared is equal to b squared. And likewise, if I take a look at right triangle number 2, we have x here, we have a, and we have h. So in right triangle number 2, we have x squared plus h squared is equal to a squared. Now, this doesn't really help us right now as per se, but if we look to start eliminate the h's and the x's, because our ultimate goal is to create relationships between the sides of the triangle A, B, and C, and maybe another angle. Well, how do we go about doing that? Well, the c minus x here, quantity squared, is equal to c minus x times c minus x. So if we FOIL this out, we get c squared minus 2cx plus x squared. Also, if we take a look over here, h squared is equal to a squared minus x squared, subtracting x squared from both sides. So h squared is equal to a squared minus x squared. So if we start using some substitution ideas, here's an h squared we could replace with what it's equal to. A squared minus x squared. This can go down here. So we have plus c squared minus 2cx plus x squared is equal to b squared. Now we start getting some action going on here because we have a minus x squared and we have a plus x squared. These will cancel out for us. So rewriting this, and I'm going to just rewrite this with my b squared in front. B squared is equal to a squared plus c squared minus 2cx. I'm just putting the b squared in front, so we have a squared plus c squared minus 2cx. What we've now done with the substitution is we have been able to take this equation that we have and eliminate all the h's, and the only thing we have left is just an x. Well, if we take a look at this triangle up here, here's angle B, here's the length of the side, entire side A, and I have angle B, and I have the x. If we look at this relationship right here, we have a right triangle. Which trig ratio relates angle B to little x and little a? That's correct, it is the cosine. So we have the cosine of angle B is equal to x over a. Multiplying both sides by a, we have x is equal to a cosine of angle B. So making one last substitution here, for this value of x, we have b squared is equal to a squared plus c squared minus 2c times what we solved for up there, a cosine of angle x. Oopsie. How about angle b? This here is what we call the law of cosines. Now, if we take a look at this law of cosines, what we have here is basically a Pythagorean relationship at the beginning. B squared equals a squared plus c squared. That looks like what Pythagoreans would talk about. We have little b here being squared. We have angle b at the very end. These are bookends to each other. Here we have a squared and c squared. Here we have a and c. So if you remember back, you should hopefully recall a lot of this stuff from trig class. We have three equations that we can write for each triangle with the law of cosine. My second one, if I start with a squared, that means at the very end, I need to have the cosine of angle A. My other two sides being squared, which is b squared plus c squared. Minus 2, and then I just rewrite what I have here, b and c. And lastly, we could write one starting with c squared is equal to, well, that would be the cosine of angle c at the end. My other two sides being squared, a squared plus b squared minus 2ab times the cosine of angle c. Every triangle will have three law of cosines equations that you can utilize. Hopefully you're remembering this. Let's take a look at the back. Triangle rat. Triangle rat. We deal with triangle rat. Once again, get a picture down. Draw a picture, draw a picture, draw a picture. Again, as you remember, all my triangles look pretty much the same. Here is triangle A, R-A-T, rat, or tar, or draw. Doesn't matter which side you label, which angle you label which angle. I just go, as how I am, I go top and then I go left to right here. Just throw in little letters, big R, little r, big T, little t, big A, little a. We have little r is a value of 10, we have little t is a value of 7, and we have angle A is 71. And we want to solve for little a here. Well, let's write, we have one angle here. We have one angle here that we know. Okay, if you remember back, if we want to write our three equations, we have r squared is equal to a squared plus t squared minus 2at cosine of angle r, big R, little r. Or we have a squared is equal to r squared plus t squared minus 2rt cosine of angle A. Once again, big A, little a. Or we have the third one, t squared is equal to a squared plus r squared minus 2ar cosine of angle t. Those are our three law of cosines equations. And once again, hopefully, as you write a couple of these, you'll remember how to write them out. Well, we're given angle A. And the only one that involves angle A is this, the middle one. So we have a squared is equal to r squared plus t squared minus 2rt cosine of angle A. Well, substituting our values in, a squared we don't know, r squared is 10 squared, plus 7 squared minus 2 times 10 times 7, cosine of 71 degrees. Now, if you remember, what we can do with this is we can clickety-clack this straight through the calculator. we have 10 squared plus 7 squared minus 2 times 10 times 7 cosine of 71. We get 103, but that is what a squared is equal to. We have 103.42. That is what a squared is equal to get our value a. What do we have to do to both sides? That's correct, we square root. Square root. So a would equal a value of the square root of our answer. So we go second square root, second answer, 10.2 or 10.17. If we take a look at an angle, if I'm given 3 sides and I want to find the angle. Well, we have triangle BMX. Once again, I label this top is my first, left to right. If you want to label it some other way, that is fine. We have little b here. We have little m here, we have little x over here. X is 8, m is 6, and b is a value of 12. And what we want to do is we want to use our law of cosines to be able to calculate an angle. Well, an angle doesn't matter. Well, I'm just going to do one. I'm going to do angle B. The angle appears once again at the end, so we have the cosine of angle B at the end. If the angle B is at the end, what's at the beginning? That's correct, little b. So we have b squared. And then we can fill in the rest of our law of cosines equations. M squared plus x squared minus 2mx. So plugging in my values, we have 12 squared is equal to 6 squared plus 8 squared minus 2 times 6 times 8 cosine of angle B. And we can solve for our angle B. Now to solve for this, what we did before, this is what I suggest you do, subtract off your 6 squared and 8 squared and find a value. So we have 12 squared minus 6 squared minus 8 squared. That comes down to a value of 44. On the right hand side, take these 3 values and multiply them together. We have negative 2 times 6 times 8. That gives me a negative 96. So we have a coefficient there because what we'll have to do is divide by this coefficient. So these go away, and then to get rid of cosine from both sides, we have to inverse cosine. Now this is what you can clickety clack to the calculator. The inverse cosine of 44 divided by 196. Second cosine 44 divided by negative 96. And we get 117.3 degrees. Going down to our last type of problem here. Now, the one thing we have to watch out for, once again, is called the ambiguous case. This was our angle side postulate that we couldn't use in calc or in geometry class. But if I take a look, I want to try to find little a. What I have is angle B, I have little b, and I have little c. So what this will allow us to do is to find angle C first if we use our law of sines. Well, if we use our law of sines, we have the sine of angle C over 8 is equal to sine of 50 over the value of 7. So we can cross multiply here. So the sine of angle C is equal to 7 sine of 50 divided by 7. Divided by 8. That would be 8 sine of 50 divided by 7. So we have 8 sine of 50 divided by 7. We get 0.8754. But to solve for angle C, we have to take the inverse sine of both sides. So we can take our inverse sine of our answer, and we get 61.1 degrees. But if you think back and remember back to our trig class, what we had to watch out for, when we take the inverse sine to be able to calculate a value, we come down to two solutions. We have this value, which is the principal value, but then we have a second solution we have to worry about, which is its supplement. So the supplement of 61.1 is 180 minus 61.1 degrees. So we get a value of 118.9 degrees as a second angle. And what you have is you have two different possibilities here for this angle C. And I've drawn both of these possibilities here. Well, if angle C is 61.1, angle B is 50, that means the measure of angle A is going to equal 50 plus 61.1, and we have to subtract that from 180. So we have 180 minus 61.1 minus 50, we get 68.9 degrees. Over here, my measure of my angle is 118.9. I get 180 minus 118.9 minus 50. We get 11.1 degrees. Which would look like both of our pictures up here. Once I find both those angles, I can find measures using my law of sines. If I have 68.9 degrees, we can have the sine of 50 over 7 equals sine of 68.9 over little a. Here in the second one, we can have the sine of 50 over 7 equals sine of 11.1 over little a. And use our law of sines to be able to calculate our values here. So we have 7 sine of 68.9 divided by sine of 50. I botched that up. 7 sine of 68.9 divided by sine of 50. We get 8.5 here, and over there, if we look at the second one, we have 7 sine of 11.1 divided by sine of 50. We get 1.8. Or 1.759. So this is our law of cosines to be able, our law of sines and law of cosines to be able to solve, once again, triangles. This will be the last of new material for this week. Once again, I'll post a worksheet for you to be able to work on to give you some additional practice with the law of sines and law of cosines. Just remember, when you use law of sines to be able to find a value, an angle, you have to be able to use, maybe come down to two solutions. Okay, so just watch yourself when you're using law of sines to be able to find the measures of angles. Other than that, I have nothing else for you. Miss you guys. Wish we were back in class here. Please continue to keep up with the work. You've been doing a great job with that. Please keep up with the work though. Other than that, adios. I'm out here. Have a good day.